Now, just before running this to see how it looks like and if it's correctly breaking down the expression as we think it will, we are going to add one more thing here. I just noticed that I didn't add an ASCII art. If you are doing ASCII art, you definitely want to split each one of these with ASCII art. So I forgot to add it after the operator and also after the symbol. And then I'm going to add it right now, and then we can test and see. So you can test to see like if it's breaking down right now the expression properly. Because if the expression is being broken down properly as we have seen and we have gone through in our examples, then it's going to solve this properly as well. So again, don't forget to file save. You can do a Command S or a Control S as it's giving you a shortcut here. So you got to save your program first and then you can run it. So I'm going to click on run. And then we enter an expression and just see if it breaks it down to split it into the first expression, the symbol, the second expression, the equal sign, and the third expression. So I'm going to go with the first example. I'm actually going to put the same expression as given in the example. So it's 2s, right? And then there's no spacing, so plus sign, and that's equal to 2s plus 76, and that's equal to 89, right? 89, there it is. So you can see that it is correctly doing its work as we expected. It's breaking my first expression to the 2s, and then it's breaking the symbol, the operator, which then it now breaks the second expression to 76, then the symbol, which is the equal sign, and then of course 89 as well. So you can try running this with a different symbol. Let's try doing minus. So I'll do the first example. So the first example would be, or you can even do the second and put like, check if it works. Actually, we put a number first. So here I'm going to do 87, and then it's going to be minus 4t, and then it's equal to 99. And then hit enter. And you can see it's breaking it down properly as well. So it's getting the number first, then it's getting the operator, which is minus, then it's getting the second expression, which is 4t, and it's getting the equal sign, and then it's getting the last expression, which is 99. So it is breaking down successfully, and this is something to be happy about because this just means that you're almost done with this by about 50%. It works efficiently, and that's what you wanted to do. So I'm going to kill the terminal, and then let's get back to the program because we still need to do the part where we actually solve it now. So the part of solving, making the compiler solve this, now that we've broken the expression they've entered successfully for either 1 or 2, we're going to make the compiler solve it. So this is what we'll do. We'll put an if sign, an if condition. We'll say, now we need to make the compiler understand what sort of expression it is, as I've said already. Is it an expression where you have the number and the variable first, or is it an expression where you have the number first? So we're going to be using some of the string method that we've studied in this tutorial, in this lesson tutorial. We studied the string method as isDigit, which basically checks if all the string is digits. Or we studied isAlnum, which checks if all the string is alphanumeric. And you can see that's going to be useful here because if it is alphanumeric in the first expression, that means this is the type of format of linear equation they're entering. But if it is digit in the first expression, then it means that this is the type of format of linear equation they're entering. So we're going to use that if statement, and then you're going to also see how we're going to make use of the check1 and the check2 Boolean variables that we created. So we're going to use them right now. So we're going to say if, make sure your if is on the same line as your print statements that we just printed out right now. So make sure it's on the same line. So we're going to go if, and then we're going to say if expression 1, because that's like the first thing we want to check. If it is a digit, so if is digit, we're going to use the string method. So saying that if it is all digit, and expression 2, because that's what comes after the operator, is alnum, which means alphanumeric. So we're basically checking to see if it is going to look like this, right? Digits, then alphanumeric definitely is this format. But here we have alphanumeric, then digit, that's that format. So we're checking to see which sort of format it is going to look like. So if expression 1 is digit and expression 2 is alphanumeric, then we're going to use this check1. We're going to set check1 equal to true. Okay, we're changing it from false to true. Check 1 is going to be true, and then check 2 is going to be equal to false. So this is how we're going to make the change. So we're saying check 1 is true and check 2 is false. Remember, we have check 1, check 2 right here. So we're basically equaling them to true or false. So that's what we're doing. So we're checking to see that initially they would go as true false. And so we're using that to a Boolean command. So we're saying check 1 is true, check 2 is false. It has nothing to do with this, guys, by the way. It has nothing to do with the index positions. It just is check 1, check 2 is just the variable that we created that happens to be what we're using for this check. You could have called them different names. It doesn't really matter. But what we're trying to say is that we're just saying that check 1, which is the variable that was false, is going to go to true, and check 2 is going to go to false. So we're saying check 1 for expression 1, check 2 for expression 2. So it has nothing to do with index position. It's just the variable we created to use to be able to make the compiler understand what sort of format of linear equation they're entering. So we're going to do an elif statement. What about if it's the opposite? So we're going to say elif, or we can even do a separate if statement, so we don't have to do an elif. You could do an elif or an if, but I would say if here, so it independently checks each condition. We're going to say if expression 2 is digit, so digit, you can say expression, let's start with expression 1 first, so we don't get confused. If expression 1 is .alnum, so we're saying if it is alphanumeric, and expression 2 is digit, then in this case, check 1 is going to be false and check 2 is going to be true. So we're basically making the compiler check if this condition is true, then of course it's going to go with the first expression because this is where you have the first expression as alphanumeric and the second as digit. So that means this is the format of equation that the user is entering, so it can be solved in that way. So yeah, these flags, they just help us a lot to understand, make the compiler understand how to solve this. So we don't need to print check 1, check 2, but for the sake of if you want to test it, you can actually print to see what's going on and what kind of results it's going to return. So you can do check 1 and see what result it is going to return for you. So every time you put an equation, what result does it enter when it's in a different format? And then you can do print check 2. So this is just for testing purposes, but you can decide to hashtag it when you actually finish creating this program and you've tested everything well. So now we're actually going to do a time.sleep, which is where we now put for them the solution. Now that the compiler knows what type of format of linear equation they've entered, it's now time to print a nice solution for them so they can see the answer to their question. Now I'm going to print in color again, so I'm going to copy this color code and I'm going to paste it right here. And then I'm going to check which color I want to use. And I feel like for solution, I might go with 210, sort of like a peachy sort of color. So I'm going to change this color code to 210, and then I'm just going to come down here and then print something like solution, like that, telling them it's a solution. And there it is, guys. And now afterwards, I'm going to hit enter. So how do we do the solution? We have to use the checks. If the check 1 is true, right? If check 1 is true, that means we're going for the expression where the number comes first, and then we have the operator plus or minus, and then we have the digit and the number coming next. But if check 2 is true, then we have the digit and the number coming first, and then the complete digit coming after the operator. So just like what I talked about a few minutes ago. So we're going to do if check 1. That means if it is true. This is how you do it. This is how we do it, check if check 1 is true. We just have to say if check 1. So if check 1 is true. So here you can write a comment. Checks if check 1 is true. All right, so and if it is true, if the state is true, then we're going to go through. So I'm going to say for B in, we go through expression 2. Right? Expression 2. And so what is expression 2? Expression 2 would be the one where we'd have coming after the symbol. So we go through that expression 2, and we're going to use it to solve this question or to solve this linear equation. So remember, expression 1, don't forget, is always the first one, whether it's going to be a digit, complete digit, or it's going to be a number and a digit. So in this case, when we say expression 2, we're talking about what comes after. Because we have to go through this expression so we can split the number from the digit, and we can be able to solve it by taking this number to the other side, and in this case, subtracting that number from the number on this side, which is 45 minus 67, and then making the compiler understand that we have to divide the result by 3 in this case, right? So we split the number from the symbol, divide it by 3, and we're left with the R equal, the letter equals something. So that's what we're trying to do right now at this stage. So we're going through expression 2, and then we're going to say if B, I just used B, guys, but you can use anything you want. You don't have to say for B. You can say for something else. So for B in numbers, okay, so it's going to check in this numbers list. Remember, we created a numbers list, and see if the number that comes with that expression is existing here. And if it does, then it's going to convert that number into an actual number, because right now this is not an actual number. These are string. They're saved as strings, as text values, sort of. So we have to convert them to an actual number so we can actually perform a calculation. So what we're going to do, we're going to use the casting method that we learned in this lesson tutorial. So we'll say if it's in the number, we're going to use that divider. Remember why we created the divider in the first place? Now we're using it. We're going to cast it, change the string number to an actual number. So casting, we're using int function to do so, and we've learned about it. And in function, what it does is just gets your variable into an actual number. So we're basically just changing the string number to an actual number, to a whole number, right? So actual number, right? That's what we're doing. So we're changing it, and then now we're going to go back out, and we're going to say if b dot alpha is alpha. So is alpha, guys, remember, is a method that we use, again, a string method to be used to check if there is an alphabet existing in a string. So we're trying to find out, because remember, the for loop is going through expression 2, and it's going to find out. So if we had our expression 2 in this case as 3R, for example, it will find out if B is in numbers. So it's going to check. It's going through the first one, 3. Okay, is 3 in numbers? Yes, it is. Okay, then get it as a number, as an actual number. And then it's going to find out, okay, what about, is B an alpha? Is it an alphabet? Yes, it is. Okay, then save it as a letter. Okay, because we have to split the letter from the number so we can be able to use the compiler to solve the equation. And you're going to notice that I'm going to now use that letter variable that we created at the beginning and assign it to B, because we're confirming when it does check and it finds out that B is a letter, it will save it as a letter because we're going to use it. Now, once everything is done, all you have to do is come now and print this expression for the user. Print how it's going to look like and the solution. So the rewritten expression will be, we're going to write something like that. Rewritten equation or expression is going to be now as the letter, which is the reason why we split it in the first place. And then we're going to put an equal sign. So what we're trying to do here, I'm going to show you, is just show this letter and number, but in this case, the letter, the final equation. Actually, I'm going to change this. Instead of rewritten, I'll say final equation solution, so they know. And if you want to print this in a particular color, you can go ahead and do so. So it's going to look like the letter equal, just like how you normally solve a linear equation, equal to the expression 4. And expression 4, remember, is the number that comes after the equal sign. So that expression, and then in this case, it's going to be comma. It's going to always be a subtraction, guys. It's always a subtraction because we're not dealing with anything that's not a positive on the left side. So it's always going to be subtracting whatever comes towards it. So minus expression 1 in this case, because expression 1 is the number. Remember, this is the type of format of the equation. We're talking about this equation format. So we do know, the compiler does know that expression 1 will be a number. So it's going to be this expression 4 minus expression 1. So that's why I told you, because we're not dealing with an equation where we have a negative sign. We're not dealing with, this system does not solve these type of equations. If you want to do it, it is possible, but you would have to extend the system to solve this type of equations. We're dealing with where everything is positive here on the left side. So we're assuming this is positive. It's going to move over here. So obviously this one is going to subtract whatever moves towards it. So that's why we're doing that part of subtraction and showing it here saying minus. So it's going to display it this way. So minus expression 1. And then we're going to have a division to show that it's going to divide by the number next to the letter. Because remember, we just split here the number from the letter. So it's going to divide the number next to the letter. And we're going to say comma, because we're separating this string from the number. divider. So divider was that number that was next to the letter, which will be dividing, which will divide expression 4 minus expression 1. So essentially, if we had an equation like this, I'm going to explain here. If we had an equation, it will look like this now. It will be like 3r. Actually, it's going to be r equal the letter first, because that's what we said here. And if the number that was after the equal sign was 99, so it's going to be 99 minus the number that was like at the start, which is 89, and then all of that divided by what is the number that was next to the letter, which was like 3r, so divided by 3. So essentially, it will perform this operation first before it performs the division of the two numbers. So that's what's happening. And the next thing we're going to do after we do that is, this is just showing it. This is not solving it, by the way. It's just showing how the expression would look like. Okay, but solving it, we're going to have to put this in parentheses. We're going to have to group stuff. And we also have to convert this expression 4 to an actual number, just like what we did here. We have to cast it. Because remember, expression 4 is storing as a string, right? It's storing as a string, as quotation marks. So it's not an actual number. So we have to convert it to an actual number so it can perform the operation. So this here is just displaying how the equation is going to look like. But now we're going to do the proper solution. So we're going to print here. So what I'm going to do is I'm going to print a nice ASCII art again. So I'll put a nice ASCII art after this. Just put a really long ASCII art like that. And then I'm going to come down, do a time.sleep for about maybe a 1 second wait, and then print the solution. So I'm going to put a color for the solution. You don't have to do this, but I just want to make it aesthetically nice. So I'm going to copy the color code. I'm going to paste it right here, and I'm going to take this out and put a number here. So the number I'm going to go with perhaps is 69. So I'm going to put 69 over here. And then I'm going to print answer, okay, because now we're doing the answer to this solution. So answer, you can do it this way, or you can say something else. And then I'll just give a space and put a comma, and answer is, you can say answer is or answer. Again, the letter is going to show. Then again, we're going to put the equal sign, of course, and then we're going to be casting now. So we're going to change this expression 4 to an actual number. So we're using that int cast method, which we learned about, which changes it into an actual number, minus, we're just rewriting exactly the same thing we have, int expression 1, okay, expression 1, of course. And then we're going to say, after we've done this, so this has to be grouped, okay, we have to do the subtraction first. Once we've subtracted, then we're going to divide by the divider. And that's it. That's how it's going to print the answer for you. And that's just for check 1. So this is for the expression format that goes as, for example, number 67 plus 5t, for example, equals to 78. So that's the type of format. This whole thing is for that type of format. Now we're going to do the contrary to this type of format, which is the one where instead of the number coming first, the number and digit is going to come first as the first expression. So we're going to do it right now, and that will conclude this program. So I'm going to say if this time check 2 is true. All right, so if check 2, that means it is true for this expression. So now it's going to be checking if, so the type of expression we're kind of checking is the opposite of what we've just seen. So it's like where you have 5t this time, for example, minus 67 equal to 99. So this is the format of this type of expression that we're doing now. So if check 2 in this case, then we're going to do the exact same process. There's no much of a difference. The exact same process, we can use the same variables if we want. So we're going to do 4b again, but this time it's going through expression 1. Okay, not expression 2, because expression 1 in this type of format is the one that contains the number and the digit. So the number and the letter. So here we're going to do the exact same step again. We're going to say if b in numbers, again, similar step. Then we're going to do the divider again. And you can use the AI assistant because it really just, I would say type it yourself because there might be a little glitch in the AI assistant, maybe a little change in the way we're going to write the expression. But if you prefer to use the AI assistant, just make sure you double check and see that it's going with what we're doing here. So we're going to get this divider, which is the number. We're going to be splitting the number from the letter. So in this case, we're trying to split this 5t to actually be 5 for the number and then t for the letter. So that's what we're doing. So the divider is going to be casting this as a number, as an actual number for the operation. And then we're going to do the similar thing for the letter. So we're going to say if b dot is alpha, again, that method, the string method to check if it's an alphabet, then the letter is going to be equal to b. Okay? And then afterwards, we're going to do the same thing again, where we're going to rewrite the equation. So hit enter, come down here, print. Again, we can say final equation. And how are we going to solve this? Very, very similar, but the only difference is we're using expression 2 here. So here we're going to write final equation solution, okay? And then the final equation solution in this case would be comma letter again. So we're going to show the letter again. We're going to have the equal sign. So remember, we're not solving right now. What we're doing is just showing how this is going to look like. We're going to write the actual solution on the next line, which is where we say answer is. But we're going to show expression 4, which is, again, always the expression that goes after the equal sign. So that's going to be the digit after, and then that's the expression 4. So it's going to be that, and of course, minus the expression, in this case, 2, right? Because expression 2 is the one that would be this number right here. So that's going to be minus and then comma expression 2, okay? And then, of course, we're going to have divided by the divider, whatever the divider is. And so that means the number that's next to the letter, in this case, like 5. And then we come and print the actual answer. So again, I'm going to use that whole, you can use an AI system here because it just gives you what you need. So I put the ASCII art and I waited for 1 second, put the color again, and then I did the answer is the letter again is going to be equal to, and we cast again, we convert this expression 4 to a number, minus expression 2, which is also converted to a number. We do that operation first, we minus them first, then we divide them with the divider, which means whatever is next to the letter. And this concludes this program, and this is kind of the end of the program. You can, however, if you want, ask them if they would like to solve this again, or you can print a goodbye message and just end it. So I'm just going to print a goodbye message after perhaps a 1 second pause. It's going to print a nice message saying, thank you for using this program. So I'm going to, again, go with the color code, and I probably will go for my goodbye message. I would use 161 for color. So I'll print paste and then change this one to 161. And then I'll just print a nice goodbye message and say, thank you for using this program. So I'm going to print an ASCII art here first. Okay. And then I'm going to print the goodbye message and say, thank you for visiting, because it's a Linea Diner, for visiting the Linea Diner. Okay, so something like that, and I will just extend my ASCII art right here to the end, and then just basically do print, and then, yeah, like that, and then just maybe do like an exit. So instead of that, I will just do an exit, and that means that the console closes. That's pretty much what will happen. Yeah, and that's pretty much it. Now we just have to test and run and see if everything's working fine. This concludes the Linea Diner program based on the programming scenario that you were given. So remember to save your program at this point, based on all the changes that you've made. Save it before you actually run it and test it. So you have to test it for 2 things. You have to test to see if this type of an expression is working and solving, and if this type of an expression is actually working as well. So let's run it and see. So we're going to click the run button here. And the first thing we'll do is try 2 of those expressions. So we'll try the first one, sort of like the first format. I'm going to try number 1, hit enter. I'm going to enter the expression. So we can enter the one given as the example, 2s, and then we can say plus 76. And then that's going to be equal to 89. And there it is, guys. It just gives me my answer right now. It tells me, okay, we have 2s plus 76 equals 89. So we have check 1 as false and check 2 as true. Obviously, because check 2 will be true since it's starting with the number and the variable. Here we have S is equals to 89 minus 76 divided by 2, which is true. And that's going to be giving you 89 minus 76 is going to give you 13. And so 13 divided by 2 will give you your answer of 6.5. So it does work pretty well. So the first expression is working perfectly. Let's run and see the other type of format of expression. So any algebraic expression that you try in this is going to work as long as it's fitting these two formats. So here we're going to do the second one, okay? And we're going to put the 87 without spacing, 4t minus 4t, and that's equal to 99. And as you can see, it's giving me my expression again, my answer. So it's splitting this into 87 minus 4t equals to 99. This time, check 1 is true. Remember last time, check 1 was false. Just recalling that, but check 2 was true. So now check 1 is true, and you can see it's doing 99 minus 87, right? Because it's taking that 87 to the other side, and then divided by 4. So here, the only thing that I would say that is not very efficient is that it's supposed to give you that negative sign, because obviously here we have a negative number. So it's supposed to have t equals to negative 3. Because here 99 minus 87 is obviously going to be 12, and so 12 divided by 4 is correct. It's going to be 3.0. But again, because there is a sign here, we have to check if that expression is a minus. You can fix this really quickly. If it's a minus detected, we're actually going to fix it. If it's a minus detected, then it will return the answer as just minus 3.0. But if a positive is detected next to this second expression, then it will return the answer as positive 3.0. So that's the only thing you need to modify, because you need to make sure the answer is returning correctly. So here it's supposed to be negative 3.0. So we're going to do a little fixing for that one. To fix that little problem that we were talking about where it doesn't detect if there is a negative sign or a positive sign next to the letter and the number in the letter, what you can do is go back to your if check 1 in your program, and first we're going to just fix the display where it shows that if it's a negative or a positive sign that's in front of that number next to the letter. We're going to use the symbol variable. If you remember, we have a symbol variable here that we assign to whatever symbol was detected in the expression. So we're going to use the symbol variable to basically put the right sign in front of that number. So here I'm going to come again to this if check 1 area, and then in front of this, just before the divider, I'll put symbol, and then I'll put a comma so it shows the symbol, whether it's a plus or minus. Now here in the part of displaying the answer, just before you display the answer, you have to show if the symbol is a positive or negative. So what I'm going to do is I'll put if symbol. Okay, so we're using that symbol variable is detected as to be a positive, then nothing's going to happen in that case. It's just going to show this answer the way it is. You're not going to add any sign to the final variable. So it's just going to show this answer. So you just have to space it in. Use your tab key on your keyboard. However, if symbol is detected as a negative, this is where you're going to add that negative sign to the final answer. So here, if symbol is detected as negative, then you would hit enter, and then of course you're going to print. You can just copy this this line because it's the exact same thing. The only difference is you're going to add a negative sign to the final answer. So that means you're going to say equals to whatever the final answer is going to give you, and you just can put a negative sign in front of the equal sign, which is going to be close to the final answer. So that's what you can do. And then you do the same thing for check 2 as well. So check 2, you do the same thing where you adjust the print for the expression right here, where you add that symbol variable that we're talking about, and then the divider. And the same thing goes again here where you add that if conditional statement to determine if the symbol is positive. Then again, it will just display the answer as it is. It doesn't change. But if it is negative, then it will add that negative sign to the answer. So here I'm saying is symbol equal positive, then space this in. That means it shows the answer as it is. However, if symbol equals negative, then you can use the AI assistant and just double check. It's going to show the answer with a negative sign. And of course, there's a subtraction. So that's pretty much how you can fix it, as simple as that. You just use a symbol variable because you already have that variable saving whatever symbol it is. So now you just need to save and run again and see that everything works. So I'm going to take the terminal up and I'm going to run again. So make sure you saved. And once you run again, now we're going to try that expression that we had from the beginning, that one that was, the second expression. So it's compiling for us and it's starting to run. And now I'm going to do the second expression just like we did before. So I'm going to type in 2, hit enter. Let's put the exact same expression, or you can try any expression you want as long as you just have a negative sign so you can test to see if it works. So I'm going to say 87 minus 4t, and that's going to be equal to 99. Now let's see if we're going to get negative, I think it was negative 3 that was supposed to be the answer. There it is. It's giving us a negative sign, and it is showing the symbol here as negative 4. So that fixes that. Let's run and let's try putting a positive value, and let's see if it recognizes it as just positive. So if it was 87, I'm going to put the same equation. Oops, here we got to put 1 or 2 first if we want to do equation 1 or 2. If I had put that 87, it will give me an invalid input. So I'm going to put equation 2 type, and then I'm going to write the expression. So let's say it was 87, but this time plus 4t. Is it going to show us the difference of positive 3 instead of negative 3 now? So it's going to be equal to 99. And so now we're going to run it and see. So hit enter. Let's see what the result will be. And it's giving me positive 3. And you can see that it's returning positive 4. So positive 3 is the answer. So that just fixes the problem. It now works properly. And we have concluded this linear dyna program based on the programming scenario that was given to you. Now you will be expected to complete a knowledge test quiz or a knowledge quiz that basically just tests to see if you've understood everything you've learned in lesson 1. At the end of looking at all of the questions of the knowledge quiz, you will have an answer key that you can use to compare and see how much you score on the knowledge quiz. So let's have a look at the knowledge quiz. Here's the Python quiz that you'll need to complete to basically test your knowledge and see if you've understood everything we've learned in this lesson tutorial. So I would like you to pause the video and look through the questions and answer them. Make sure you have a notebook and a pen with you or a pencil so you can put in your answers, and towards the end you'll have a marking scheme where you can compare the answers with the answers you've written and see how many questions you get correct. Good luck! Here is the marking scheme, so compare your answers and see how many questions you got right. I hope you do well in this, and I will be seeing you in our next lesson tutorial. I'm looking forward to it, and have a great day, or evening, or night, wherever you are. See you soon.